Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Hasna, and today I want to share with you about my research that is a title is Effect of Dataset Imbalance Handling and Feature Selection on Improving Fetal Wellbeing Classification Accuracy Based on Cardiotocography or CTG data. So our table of content is introduction and literature review, methodology, and also result. So globally, the WHO reports approximately 2.5 million is stillbirth is death annually, and in Indonesia itself, based on the latest data from 2023, the angka kematian bayi or IMR is still above 15 per 1,000 live births. This figure indicates that more than 15 infants die for every 1,000 live births, a number that we still require significant effort for reductions. And one of the main contributing factors of this high IMR is fetal distress. Fetal distress is a condition where the fetus experiences oxygen deprivation and it's at a high risk of serious complication, even death. And fetal distress is often difficult to detect manually. So this is where the crucial role of cardiotocography comes in. And CTG records the fetal heart rate and uterine contraction, that providing crucial information about fetal well-being. However, the complex interpretation of CTG data often requires a specialist expertise that, particularly in Indonesia, is unevenly distributed. So, machine learning technology offers an innovative solution to address this challenge. With machine learning, we can develop systems capable of analyzing CTG data automatically and objectively. So after we know this, we arrive at the following problem statement that a machine learning based system is needed to simplify CTG interpretation, improve the accuracy of fetal well-being classification, and reduce infant mortality rate. After we know the urgency of the infant mortality rate issue and the potential of CTG, we will now discuss into the literature review conducted for this research, focusing on relevant papers explore for machine learning uh, for CTG data. So our literature review is identifying existing research that utilize machine learning techniques for CTG data analysis, and the primary dataset used in many studies in the paper is including the fetal health classification dataset that available on Kaggle. And for the data preprocessing is a very crucial step in machine learning, and that there is several techniques that have been employed in the literature review. This includes normalization, smoother for balancing dataset, and feature selection that include ANOVA, chi-square, and mutual information. And for the feature extraction method from the CTG data is the common features method extraction method that have been used are baseline fetal heart rate and also acceleration and deceleration and uterine contraction. And more innovative techniques such as kernel density estimation and generative adversarial network have also been explored to extract more complex and informative features. And for the machine learning models, is has been applied to CTG data include machine learning model like random forest, gradient boosting, and support vector machine, and also k-nearest neighbors. And for the deep learning, include deep neural networks and type 2 fuzzy neural networks. And based on this literature review, we have reported that the high accuracy in the literature review is 99% using the NN. And furthermore, there is an ensemble method that have an accuracy reaching 99.5%. So this is consistently demonstrated the preprocessing and data balancing are crucial for improving data quality and model performance. Based on the literature review provided before, we use our selection methods for our own research, which we will discuss in the methodology. So the research methodology can be seen in this figure, which outline the process of developing a machine learning model for our classification. And the process begins with the CTG dataset, which provide the CTG data that contain measurement of fetal heart rate, uterine contraction, and other relevant parameters. And after that, there is a stage preprocessing that is preparing the CTG data for machine learning, and it include the data cleaning, outliers handling, oversampling, and normalization. So after this stage, we reach the filter selection stage, which we use the correlation heat map and ANOVA test, which is the ANOVA test is a statistical test uh, to help our research to identify features that are significantly different between different fetal heart class. And for the machine learning model, after the feature selection stage, we train the model with supervised machine learning and also ensemble machine learning, such as voting classifier. And after that, we evaluate our model with the performance evaluation with accuracy, ROC, recall, F1 score, and also conversion matrix. And after that, we have a result that divided into three classes, which is normal, suspect, and pathological. So after we use that methodology, we have a result that have been shown in this table. We can see that we have a highest accuracy in a model like GBM, which is 98.18%, and also the voting classifier is reaching the high accuracy with 98.04%. And for the better visualization, we use this uh, graphical bar for comparison of testing accuracy across models. And we can see here that light GBM has the highest accuracy amongst all the models. And for the conversion metrics that summarize the model's classification performance, we see that this matrix illustrates the prediction result of the light GBA model on the test data. The vertical axis represents the actual levels, and the horizontal axis shows the predicted levels. So the numbers we see is the main diagonal of the matrix, which represent the correct predictions. We can see that the model successfully predicted a level 1 or normal class for 491 data points, and for the class 2 or suspect is 475 data points. And for the class 3 or pathological, we can see that it has a 489 data points accurately. So this demonstrated very good performance for all three classes. However, we see that there is a minimal difference between light GBM and voting classifier. We can see that in the light GBM, uh, for example, there is 10 data points that should have been labeled as normal class were predicted as suspect class or class 2, and there is 2 data points labeled as normal class were predicted as pathological. And but overall, the light GBM model has so the highest accuracy and higher accuracy than the voting classifier with minimal predictions error. So this proves that this model is effective in classifying data on the CTG dataset. So we reach the conclusion that the application of the oversampling technique using SMOTE can balance the class distribution in the dataset. The number of samples for all three target classes becomes balanced with 1,649.46 samples per class, and furthermore, the feature selection using correlation, heatmap, and ANOVA tests can improve model performance, and we reach the highest accuracy achieved is with light GBM with 98.18%. So this is our references for our research. Thank you very much.